G'day pilots, Captain Mulch here for Oz Aviator. Today we're going to start ground school. Stay tuned. G'day everyone, I'm Captain Mulch and welcome to Oz Aviator. I'm an Australian GA and Recreational Aircraft Australia flight instructor, and this is the first of the Aviator Ground School lessons for Oz Aviator. Now the lessons are based on the Australian Civil Aviation Safety Authority Manual of Standards, and in this series I'm going to be doing here is each section of the Manual of Standards will be covered in sequence. Now, this is mainly aimed at fixed wing pilots, but there are sections of the Manual of Standards that cover curriculum for both fixed wing, helicopter pilots and other aircraft. This first one, which is Basic Aeronautical Knowledge Terminology, is a general one for all pilots of all types of aircraft. Now, I'm not going to go into any of the material in depth, so I strongly encourage you to do further online learning and also make use of books such as the very good Aviation Theory Centre series of books which are available online. And there's also Trevor Tom, who's an Australian who specialises in aviation theory. Trevor Tom stuff's really good too. Okay, so first of all, I'm just going to go through the slides which I have that cover the basic aeronautical knowledge terminology. And if you have any questions or any suggestions, please put them in the comments below, and I can chase that up for you. So without further ado, let's have a look at the slides. Okay, basic aeronautical knowledge terminology. So the first thing is the description of the direction of flight using the following methods: 3-figure group as a 2-figure group, clock code, and defining the meaning of aircraft heading. So 3-figure group, compass is divided into 360 degrees, and the direction that you're traveling refers to the direction on the compass in which you are traveling, and we use a 3-figure group for that. So if you're heading north, 360 degrees, and you don't say 360, you say 360. If you're heading 040, this direction, you're heading due south, 180, heading in this direction, 200. A 2-figure group is mainly used in relation to the direction the aircraft is traveling on a runway, so a runway heading, either takeoff or landing. So if the aircraft is heading in the direction of 220 degrees for takeoff or landing, the runway, because the runway points in roughly 220 degrees, that runway will be referred to as runway 22. If the runway is heading 040 degrees, the runway will be referred to as runway 04. So they just drop off that last zero. Clock code. Clock code is used to refer the aircraft in relation to a position of other aircraft. So 12 o'clock is always the nose of the aircraft, 6 o'clock is always the tail, 3 o'clock is always off the right-hand wing, 9 o'clock is always off the left-hand wing, and then points in between that, 1 o'clock, 7 o'clock. Now the way, when you use this is, say you're out flying with your flying instructor or with another pilot, and you're both looking out for traffic, to tell the other person where the traffic is. If there's an aircraft off your right-hand wing, you say aircraft at 3 o'clock. If the aircraft is off your wing and above you, 3 o'clock high. If the aircraft is off your left wing below you, 9 o'clock low. This may also be used by air traffic control if they're wanting to alert you to another aircraft in your vicinity. Air traffic control may say there's an aircraft at your 3 o'clock, which is saying there's an aircraft off your right wing. Define the meaning of aircraft heading. Okay, so in navigation, the heading of an aircraft is the compass direction in which the aircraft's nose is pointed. It doesn't necessarily mean that that's the direction the aircraft is heading in over the ground, but it's the direction the aircraft is pointing in. So as you can see here on the diagram, the aircraft may be pointing in the direction of 090 due east, but because of the wind, the aircraft track over the ground is 110. The aircraft is still heading 090, but the track is 110, but heading is still 090. Direction of flight, the differences in the following terms used to describe direction: true, magnetic, and compass. So the Earth has a geographical North Pole, also geographical South Pole, which does not move. It's a position on the Earth which is always fixed, and the lines on the map are always drawn in relation to that true North and South Pole. The magnetic North Pole, which is what your compass points towards, the north point of your compass will point towards the magnetic North Pole. The magnetic North Pole varies over time. It doesn't change a lot. It doesn't change quickly over time, but it does change over time. So you may be heading towards the true North Pole, but your compass will be pointing towards the magnetic North Pole. How do you take this into account? If you look at the map, you'll learn to do this in navigation. But on most maps, you'll see a line drawn in this way, which is called an isogonic line. The isogonic line will have a reference on it. This one, for example, has 7 degrees east, which means that your magnetic variation in that area, it varies over the different parts of the Earth, but in that area, your magnetic variation is 7 degrees east. So true north is the geographic North Pole. Magnetic north is the compass pointing to the magnetic North Pole. Now compass north, the magnetic compass in your aircraft is subject to a slight deviation caused by the magnetic influence of bits of metal in your aircraft, ferrous material that can make your aircraft's compass deviate from what the magnetic north is. Now, what happens with your aircraft is they take it out, the aircraft engineers take it out and swing it on a compass circle, it's called. It's a point on the airport which is away from other magnetic influences, and they can determine what the magnetic deviation of your compass is. And they'll write this on a deviation card. You'll notice in every aircraft you fly, there'll be a deviation card. The deviation card shows how much your magnetic compass is varying, or deviating, I should say, from the magnetic north, south, east, west, the different points of the compass. And you need to take that into account when you're navigating your aircraft. So as an example here, your aircraft is heading true north here. This is true north, as noted on the map by this meridian of longitude, it's called. So your aircraft is heading true north, but to do that track, that true north track, the magnetic variation in this part of the Earth is 7 degrees east, We say east least, west best. So east least, you subtract that 7 degrees from the true north heading. So your heading will be 353 degrees magnetic. Take into account the 7 degrees east variation. So if your aircraft is heading 353 degrees magnetic, it will be actually heading 360 degrees true north. And then to take into account the deviation, so that previous compass deviation card I showed you, that for north, the deviation was -1. So you need to actually, on the compass, have the aircraft heading 354 degrees, and that will actually be 353 degrees magnetic. Distance, speed, and velocity. So state the units for lateral distance in respect to the following. Navigation, visibility. We need to define the meaning of what a knot is when it's used to express aircraft speed, how we refer to wind velocity, the speed of the wind, and then differentiate between the following acronyms. IAS, indicated airspeed, CAS, calibrated airspeed, TAS, which is true airspeed, and GS, ground speed. So when you're navigating your aircraft in Australia, the distance travelled is measured in nautical miles, which is an old standard from the days of sailing, early days of sailing. It was determined nautical miles. You'll learn about that more in navigation, how nautical miles are determined. But nautical miles are 6,076 feet or 1,852 metres. It doesn't matter, what's a nautical mile, because you're using a map that has nautical miles on it, and also because you have a airspeed indicator which is measuring your speed in nautical miles per hour. It's all relative, so you don't need to worry too much about how far it is in feet and meters. Just know that it is nautical miles. Visibility. Visibility is the distance you're able to see. When you're in the aircraft and you're looking out, the visibility is referred to in meters or kilometers. So you'll see meters and kilometers used in things like forecasts or warnings about certain things. When you learn to do navigation, you'll see that the forecast for visibility is in meters or kilometers. The aircraft speed is measured in knots, which is nautical miles per hour. Do some research about that online, why it's called knots, but it's an old standard. And wind velocity, which is the speed of the wind, is measured in knots. And what I've got here is a diagram showing a windsock at an airport. Windsocks are what they call standard 15-knot windsocks. So if the windsock is sticking straight out in the wind, that means that the wind is 15 knots or more. If your windsock is hanging straight down, no wind, 0 wind, and then between that you extrapolate between the no wind and the 15 knots to determine whether the wind's 5 knots or 10 knots, gives you a relative good idea of what the wind velocity is. Indicated airspeed. Now, indicated airspeed, it's the speed of the aircraft as indicated on your airspeed indicator. Now, this airspeed indicator has both miles per hour and knots on it. A lot of the American aircraft have both of those on it. We're only interested in knots in Australia. So if your airspeed indicator is pointing at 80, you're doing 80 knots indicated. Now, calibrated airspeed is your indicated airspeed corrected for instrument and position error. So the instrument's not perfectly accurate, and the place where the airspeed is measured is not completely accurate. But what happens when the aircraft's made, the engineers take the aircraft out and they test it with the standard instruments and the standard setup of the aircraft, and they determine how much the indicated airspeed varies from what the airspeed actually is. This gives calibrated airspeed, and you'll see most aircraft pilot operating handbooks have a chart in there which will show you how much the indicated and calibrated airspeed vary. It's usually not a lot, but for accurate navigation, it's good to know. Now, true airspeed is the actual speed of your aircraft relative to the mass of air in which the aircraft is traveling. So, true airspeed varies. If you're at sea level and in standard conditions, your true airspeed is going to be fairly close to your indicated airspeed. But the faster aircraft go and the higher they go in the atmosphere, the true airspeed will vary. This airspeed indicator has a little knob on it for calibrating the airspeed indicator for temperature and air pressure, and it will then give a true airspeed of the aircraft. This is more important in more high-speed aircraft that go faster, more high-performance aircraft. In your little training aircraft that are usually operating at low levels and low speed, it's not going to, your true airspeed isn't going to vary greatly from your indicated airspeed. And ground speed is just the speed of your aircraft over the ground. So not worrying about anything else if you're just looking at a spot on the ground, say you're over one town, and then you fly to another town and you can pick the exact spot over that town and you measure the distance and the time it took. That is the way you determine your ground speed of the aircraft over the ground. Okay, looking at time, express time as a 4-figure group. So the 4-figure group, 24-hour time. See, a clock is, we usually work in 12 hours, AM and PM. 24-hour clock takes into account the hours for the whole day. So 24 minutes past 10 AM is referred to as 10:24. You'll see this on weather reports and other information. It'll refer to the time as, if it's 10:24, say it's local time, 24 minutes past 10, that's 10:24. 3 minutes past 3 PM, so 15:03. 10 PM, 2200. I say 2200 hours. So to convert local standard time to universal time coordinated, the reason we use universal time coordinated, UTC, is because, say, across Australia we've got 3 different time zones, and so we all know what the actual time is for an event to occur. If we use universal time coordinated, you can then take into account those different time zones and work out what the time is in your local time, local standard time. So here on the east coast of Australia, we use Eastern Standard Time, and Eastern Standard Time is universal time coordinated plus 10 hours. So Eastern Standard Time, 1100 hours, 11 AM. You subtract 10 hours because we're UTC plus 10, gives us 100 hours universal time coordinated. To convert universal time coordinated to local standard time, say on it we have a weather report and it says 1300 UTC, so we add 10 hours to that. That gives us 2300 hours Eastern Standard Time, which is 11 PM. Units of measurement. So height above the ground is measured in 3 different ways. We have height, we have altitude, and we have elevation. So height is the distance of your aircraft above ground level. So from here to here, so we're flying a standard circuit, which is 1,000 feet above the ground. The height at which we fly the circuit is 1,000 feet. Altitude is the distance of our aircraft above mean sea level for that standard setting for that day or for that time period. So the altitude of the aircraft is above mean sea level in feet. Height above the ground in feet, altitude above mean sea level in feet. Elevation refers to, say, a geographical feature such as an airfield, an aerodrome, and that is the height of the ground above mean sea level in feet. So, for example, say the airfield's here at 200 feet. The elevation of the airfield is 200 feet. The height of the aircraft flying a circuit above the airfield is 1,000 feet. So the altitude the aircraft will be flying, 200 feet plus 1,000 feet, the altitude will be 1,200 feet. Just ignore that practice exam questions. Okay. State the units of measurement to express runway dimension. Runway dimensions are always in meters. The width of the runway and the length of the runway. But you'll also see the length of the runway referred to in feet in certain publications. And the reason for this is a lot of aircraft from the States and also the UK, they still have reference in their pilot operating handbooks to how long it takes for an aircraft to take off and land in feet. So in Australia we use meters, but there's also some references in there to feet. Temperature is always measured in degrees Celsius in Australia. Atmospheric pressure, always in hectopascals. So we don't use the American, the Americans use inches of mercury. We use hectopascals. Weight is in pounds. And the reason for that is aircraft weights and always in the pilot operating handbooks in pounds. So we use pounds to work out our different weights. Volumes of liquid can be in litres, US gallons or quarts, quart being 0.945 litres, and visibility in metres or kilometres as we discussed previously. Okay, and finally, some basic physics in regards to kinetic and potential energy. So they want us to describe the meaning of kinetic and potential energy and the relationship to basic aircraft operations. So kinetic energy is the energy that an aircraft has due to its motion. So if the aircraft is going slow at its slowest speed, it has low kinetic energy. If it's going at its maximum speed, it's got high kinetic energy. Potential energy, if the aircraft's sitting on the ground, no potential energy. If the aircraft's up in the air, the higher it is, the more potential energy it has. So it has the potential to use that energy. So aircraft energy state with respect to kinetic and potential energy. So you can see here on this diagram, car works the same on a hill. We're using our kinetic energy to gain altitude and gain potential energy. So at the top of the hill, the car here has a higher potential energy. If we then descend the hill, we're losing potential energy, but we're converting that potential energy into kinetic energy. If the aircraft is accelerating, the kinetic energy is increasing. If it's decelerating, it's losing kinetic energy. If the aircraft's climbing, it's gaining potential energy. If it's descending, it's losing potential energy. This is something that you can go and investigate a bit more. Wikipedia's got some good material on kinetic energy. So that's it as far as basic aeronautical knowledge terminology goes. If you've got questions or suggestions, something you'd like covered in a YouTube video by me, please put it down in the comments below. Don't forget to press like and subscribe. That'd be great. Thank you very much. And stay tuned for more content. And until then, keep your wings level.